All right, Matt 2, here we go. Start of the second semester. We're going to do a little bit of review here. I know that you have in Math 1 already done multiplying and dividing with the exponents, but we're going to kind of build on top of this, so it's a good time to review. So multiplying and dividing with exponents. Our first question, remember your questions, you need to answer those as a summary at the very end of your lesson. So explain why 5 to the third times 5 to the fourth is not 25 to the seventh, because it's not. So what's the correct solution? So as a summary at the end of the lesson, you can just kind of write your explanation of that. All right, so when we multiply powers with like bases, now what's a base and what's a power? Well, if I've got a to the n, a we would consider the base, and n we would consider the power. Now, when we have bases and powers, this is just a shortcut for multiplying the same thing over and over and over again. So if I had something like 5 to the third, 5 is my base, and 3 is the power. And we all know that this is just saying that I'm going to do 5 times 5 times 5. So it's just a shortcut for showing that you're multiplying the same number over and over and over. All right, so if you multiply powers with like bases means the bases have to be the same. So these big numbers or variables have to be exactly the same. The bases are going to stay the same, and the exponents are going to be added together. So here I've got a base of 5, base of 5. Bases stay the same. So this is going to be 5. What do we do with the exponents? We add them. So this is going to be 5 to the 5 plus 11. And we get 5 to the 16th power. So the base of 5 stayed the same. The exponents are just adding them together. Okay, next one. My base is x. These are both bases of x. So those are like bases. So the bases stay the same. And the powers add together. 3 plus 5. This would be x to the 8th. Remember, you can always expand these if you forget what the rules are, because x to the third is x times x times x, and x to the fifth is x times x times x times x times x. And how many x's we got? We got 8 of them. That's what this is saying, x to the 8th power. All right, next part. What if we've got two different types of bases? Well, we can only add the exponents of like bases. So the a we have to take separately, and the b we take separately. So the a and the a, that base stays the same. And I have 1a over here and 4 a's over there, so that's 1 plus 4. For the b's, I have 3 b's being multiplied and 2 b's. So 3 plus 2. So this would be a to the 1 plus 4 is a to the 5th. And b to the 3 plus 2 is b to the 5th. So the like bases stay the same, exponents are added together. If they're not the same base, you can't combine them. All right, next part, coefficients and powers. So coefficients are the numbers that are out in front. They're being multiplied by the variables, basically. Okay, and anytime we come across a coefficient, it's going to behave normally, meaning if it's a multiplication problem, the coefficients will multiply. If it's a division problem, the coefficients will divide. They just behave normally all the time. It's the exponents that have the special rules. So looking at this first one, my coefficients are 3 and 4. So what do I do with them? Well, they behave normally. So 3 times 4 is 12. And then my base is x. So bases stay the same, and we add the exponents. So I get 12 x to the 16th. Okay, next one, another problem where we're multiplying. So my coefficients are -4 and 7. So I just multiply those. Negative 4 times 7 is negative 28. And then my base of x, I've got another 2 of them over here, so that's x to the 1 plus 2. I've got 5 y's here and 3 of them here, so this would be y to the 5 plus 3. So my final answer is going to be negative 28, x to the third, y to the 8. The coefficients are multiplied normally, and then like bases, we add the exponents. All right, negative exponents. When we have a negative exponent, we take the reciprocal of the base and the power. So a negative exponent means it's the reciprocal, which means we kind of flip it around. So x to the negative third is 1 over x to the third. Notice that once I put it into the denominator, the negative went away. The negative is just telling me that my 3 x's are being multiplied in the denominator, not the numerator. Now, if I had 1 over x to the negative third, again, we take the reciprocal, and this would be x to the positive third. So this would go to the numerator. Okay, so on this next one, now the base is y and the exponent is negative 1. The negative 1 does not go with the negative 5. This negative is not an exponent, so that's not a negative exponent. That's just a negative 5 out there. So the negative 5 stays the same. The y to the first goes to the denominator. However, if on this problem there were parentheses and the negative 1 were out here, that would mean all of this goes to the denominator. And we get 1 over negative 5y in the denominator. So if there's no parentheses, it's only the base, not the coefficient, that goes to the denominator. Next, zero exponents. So anything to the 0 power is 1. You probably covered this last year. The reasoning behind it was when you have something to the 0 power, you're dividing it by itself. And anything divided by itself is 1. So x to the 0 power is 1. 23 to the 0 power is 1. X to the third, y to the 0. This is x to the third times 1, which is just x to the third. So anything to the 0 power just becomes the number 1. All right, so let's take all that stuff and put it all together here. Okay, so I've got coefficients. This is a multiplication problem. So I'm going to do negative 3 times 5. Those are my 2 coefficients. I get negative 15. For my base of x, I've got 5 and negative 6. So I'm going to do x to the 5 plus negative 6. For my y's, I've got 0 plus 4. So what does that leave me with? I've got negative 15. 5 minus 6 is negative 1, so this is x to the negative 1. And 0 plus 4 is 4. Now, when we do our problems, our negative we can't leave our answers with negative exponents. So what we're going to have to do is take anything in the end that has a negative exponent and put it in the denominator. So my final answer for this one would be negative 15. Remember, that's not an exponent, so that's just a negative number. It doesn't mean flip it. It's when it's an exponent that means you need to take the reciprocal. Y to the fourth, that's a positive exponent, so it belongs where it was at. And it's the x to the first that goes to the denominator because it had a negative exponent. So negative exponents, we take the reciprocal. Basically, that means if it's in the numerator, move it to the denominator. If it's in the denominator, move it to the numerator. All right, next one. Well, on this one, I've got 3 different things being multiplied. So with my coefficients, I'll just do 2 times negative 3 times 5. So 2 times negative 3 is negative 6, and negative 6 times 5 is negative 30. x's. I've got 1x here, negative 4x is there, negative 2x is there. So this would be x to the first plus negative 4 plus negative 2. Then I've got my y's. I've got negative 3 of them here and 5 of them here. So this would be y to the negative 3 plus 5. And for my z's, I've got a z here and a z here. So this would be z to the 1 plus 0. All right, let's see what I got now. So I got negative 30, x to the 1 minus 4 minus 2, that's x to the negative 5. Y to the negative 3 plus 5 is 2. And z to the first. Okay, at the end, if I have any negative exponents, those belong in the denominator. So my final answer will be negative 30. X does not stay in the numerator, it's going to move. Y to the second stays in the numerator because it has a positive exponent. This is z to the first, so that's a positive exponent, stays up there. And it's only the x to the fifth that goes to the denominator. All right, almost there. Dividing powers with like bases. So now we're going to divide. And what's going to happen is the bases will stay the same. And the exponents are going to be subtracted now. Now, there is a good reason why we're doing this. Remember, we've got 5 x's on top. Somebody's calling me. And I've got 2 x's on the bottom. Now, what we can do here is we can reduce this x and this x, this x and this x, and what we're left with is x to the third on top. Basically what we're doing is we're subtracting 5 minus 2 and getting x to the third up there. So this would be x to the 5 minus 2, which is x to the third. All right, now again, it has to be with the like bases. So on this one, the x's go together and the y's go together. So we're going to do x to the 5 minus 2 and y to the 6 minus 8. That gives us x to the third, y to the negative 2. Now again, since we have negative exponents, our final answer can't have negative exponents in it. So the x to the third stays in the numerator, and since this is a negative exponent, we put y to the second in the denominator. All right, next one. So like bases go together, so x's and x's go together. So I'm going to do x to the negative 2 minus 5, y to the 5 minus negative 4, and z to the 1 minus 1, because these are z to the first here. So I've got x to the negative 7th. I've got y to the 5 plus 4, because it's a negative negative. So that'd be y to the 9th. And then I'd have z to the 0. Okay, so the y belongs in the numerator, because it has a positive exponent. The x belongs in the denominator, negative exponent. And z to the 0 power is 1. So we don't need it. Last one. So when we have coefficients in these dividing problems, we're just going to reduce them like it was a problem without any of the variables. So if I just gave you 3 over 27, you would reduce it. And so coefficients behave normally. So that's what we're going to do in this problem. 3 and 27, they reduce. 3 goes into 3 once. 3 goes into 27 9 times. So 3 over 27 reduces to 1 over 9. Now we're going to look at the x's. We do x to the 5 minus 6 and y to the negative 2 minus negative 5. All right, so this is 1/9 x to the negative 1 and y to the Negative 2 plus 5 is 3. Okay, so now I have to ask myself, where does each of these belong? Well, this is a negative exponent, so that belongs down there with the 9. This is a positive exponent, so it belongs there with the 1. So I'm going to do y to the third. You can put a 1 out there if you want to. You don't need it. So 1y to the third over 9x is our final answer. That's all I got. Math hard. See you later. Bye-bye. Oh, answer your question too. So you should see, especially after looking at these problems down here, you should see why 5 to the third times 5 to the fourth is not 25 to the seventh. All right, so answer that question as part of your summary. All right, see you later. Bye-bye.